right, well, welcome. We're going to dive right into a history of the atom, theories, and models. So maybe your drawing looked like one of these models. These are all models of the atom, and we're going to be looking at each model: the billiard ball model, the plum pudding model, the planetary model, Bohr's model, de Broglie's model, and Schrodinger's model. Before we get into the first model, this idea of an atom came from a Greek philosopher, Democritus. He said that matter is made up of atoms, and these atoms cannot be divided. They are indivisible, so they can't be divided into smaller parts. So from Democritus, we go into John Dalton, who developed the billiard ball model of the atom because he believed that atoms were tiny, solid spheres. He also added to his atomic theory that atoms of the same element have the same properties. So J.J. Thomson comes along and uses an experiment with electrical currents through a vacuum tube to discover these negatively charged particles called electrons. So in fact, he finds out that atoms can be divided into smaller parts, like electrons, and he developed the plum pudding model. So basically, he has these negatively charged plums, or electrons, scattered throughout the positively charged pudding of the atom. Ernest Rutherford is most known for his gold foil experiment, where he fired positive particles, also known as alpha particles, at gold foil. Now, with the plum pudding model of an atom, the alpha particles passing through the gold foil would have slightly repelled and changed their course. However, when Rutherford did the experiment, he found that the majority of the particles passed straight through the foil, with a few that bounced back. So Rutherford concluded that atoms have a nucleus with all of these positively charged particles concentrated at the center, surrounded by electrons. So this is where he developed his planetary model, with this nucleus surrounded by an empty space except for the electrons that move randomly through this empty space. And this is the planetary model because it's similar to planets orbiting a star. Thinking about the planetary model that we just discussed, it doesn't quite answer why electrons would stay around the nucleus, right? So if you have the positive particles inside the nucleus and these negative electrons surrounding it, why wouldn't the electron fall into the nucleus? So Bohr kind of tried to answer this question, and he created a model, the Bohr model, where electrons move around the nucleus in specific shells, and each shell has a different energy level. He also started to touch base on energy being emitted and absorbed, and causing the electrons to move between energy levels. Now, de Broglie's model is very similar to Bohr's. However, de Broglie contributed a lot to the quantum theory, right? So he's looking at more of the mathematical explanation for atoms and matter. And he said that all matter has wave-like properties, that electrons have wave-like properties. So his model is very similar to Bohr's, except for that as the electrons kind of orbit the nucleus, they have this wave-like property, right? These electron waves. So Schrodinger took quantum theory even further and develops the quantum model of the atom. With electrons treated as waves, he used the Heisenberg uncertainty principle in that it is impossible to know an electron's position and energy. So his model shows electrons in this cloud of probability where the electron is likely to be located. So you still have the nucleus at the center, right? But these electrons are more represented by electron clouds since their location is probable, it's not certain. So here is more of a timeline view of the history of models of the atom. Now, the only one you probably won't identify is the gentleman at the end, and that's James Chadwick, who discovered the neutron in 1932. So take a look at this and just see if you can identify each scientist with their model. I want you to go ahead and think about each model that we have discussed today, right? We have John Dalton's billiard ball model, J.J. Thomson's plum pudding model, we have Rutherford's more planetary model, Bohr's model, de Broglie's model, and Schrodinger's model. And I want you to try to identify some of the strengths as well as the weaknesses of each model, and then be able to explain why Schrodinger's is the best model to represent the structure and behavior of atoms. So now hopefully you have a pretty good idea of the history of atomic theories and models. And what we're going to do next is we're going to take a review quiz, and then we're going to compare these models even further through a PhET simulation.